Before we go on, let's try to structure our code in different regions. So one for helper methods, one for image creation, and so on. That is not really needed but makes it easier for long code to find the right place for any updates later. So looks now really structure or? Let's implement another feature for the game. What do you think about 3 lives for Pacman with 3 images that show the count to us? So if we hit by a ghost and we not in power mode, we lost a life and can go on until all lives are gone. And we can refill the lives with another power up called fruit. We can use the F for it in the map. For this we need 2 new variables. A counter from type int and an array of picture boxes for the icons. If that is done, we can create the same stuff that we used for the power pill. So first add another line to the load level. There we can add the S tile locations to the original tiles to prevent that they are eaten by the ghost. If that is done, we can add the F tile to the isWalkable method that we can walk to this tile. If that is done, we need of course also to add the F to places in our map where we want the fruits. And add the F to the update tile method together with a new method generate fruit image for the visualization. So you see it's in general the same for all add-ons that you need and easy for you to add more after this tutorial. You have the power. Let's bring some juicy fruits to the Pacman grid. This is the generate fruit image method, and its job is to draw a fruit image dynamically using graphics. Think of this as giving your game a tasty little bonus for Pacman to munch on. Let's break it down step by step. First, we create a bitmap the size of a single tile using tile size. This acts as our blank canvas where the fruit will come to life. Then, we create a graphics object from the bitmap. Think of this as picking up a digital paintbrush to start drawing. Next, we paint the main body of the fruit, a big red ellipse, right in the center of the tile. The dimensions ensure it's circular and fits snugly within the tile. Now we have the meaty part of the fruit, cherries. Here comes the shine. A smaller pink ellipse is drawn on top of the red body, slightly offset toward the center. This gives the fruit a glossy, realistic look, like it's fresh and ready to eat, glowing star. Now, every fruit needs a stem, right? We add a small green rectangle at the top of the fruit, giving it a cute little handle for Pacman to grab, symbolically, of course. Finally, we finish it off with a triangular leaf sprouting from the stem. The point defines the three corners of the leaf, and fill polygon fills it with a vibrant green color. It's the perfect finishing touch for our fruity masterpiece. And voila! We return the completed bitmap. This image will now represent the fruit in the game. Whenever Pacman encounters it, he's sure to feel rewarded. So now we see our fruit is there and we can eat it. Looks very cool, or, how do you think? Feel free to share your thoughts in the comments about that fruit or any other function. Let's create now the live icons for the game and also the function to use the lives and refill it using the fruits. We start by creating an array called life icons. Its size is based on the number of lives Pacman has, which is stored in the lives variable. Each element in this array will represent one life. Next, we loop through all the lives. For every life Pacman starts with, we'll create one corresponding icon to display on the screen. Now, for each life, we create a new picture box, a small square that acts as a container for Pacman's life icon. Set the size, each icon is 25 by 25 pixels. Set the position, we horizontally offset each icon by 30 pixels, starting from a base position of 150. The vertical position is calculated to align just below the game grid. Set the image, we assign a mini Pacman image, using the generate Pacman image method with a rotation angle of 0 degrees. Set the background, we use a black background to blend with the game's theme. Finally, we add the picture box to the form so it's visible on the screen. This step ensures each life icon is drawn as part of the game interface. So that looks pretty good. Now let's implement the last part for this, to house the lives if we have one, and also to refill it using a fruit from the map. The implementation is nearly the same than the power mode tile. First, we remove the fruit tile's position from the original tiles dictionary. Because once Pacman eats the fruit, it's no longer part of the game grid, it's gone, devoured, and can't come back. And then we call the restore lives method to restore our lives. This is quite easy and loop throw all lives after set it back to 3. Then all picture boxes are set back to visible to see all 3 of them. That's all. The last step is also to modify the game over method. Because if we have a live left, then it's not the end. Now, let's break down the game over method. This is where the drama unfolds and Pacman faces the ultimate challenge. Is it truly game over, or does Pacman get another chance to rise again? Let's find out. First, we start by reducing the number of lives. Yep, Pacman just lost 1 life. But hold on, the game isn't over yet. If there are still lives remaining, this means Pacman gets another shot. Here's what happens in that second chance. We take the corresponding life icon from the life icons array and make it invisible. This is a visual cue for the player, they've just lost one of their precious lives. We clear Pacman's current spot on the grid. Then, we place Pacman back to the starting position at 1, 1. We call the redraw game board method to update everything visually so the player knows Pacman is back in action. But what happens when Pacman runs out of lives? It's the dreaded game over. Here's what goes down. Stop the ghost timer. The ghosts stop moving because the game has officially ended. A dramatic pop-up lets the player know their fate. This message is the final nail in the coffin, better luck next time. The game gracefully shuts down. So, the game over method does an amazing job of managing both outcomes, giving Pacman another chance when lives are left, or ending the game in true Pacman fashion when the ghosts win. It's simple, effective, and keeps the player on their toes. Now, let's dive into the redraw game board method. This is where the entire game board gets a fresh coat of paint. Whenever we need to refresh the visuals, whether it's because Pacman moved, a ghost did something sneaky, or a tile updated, this method takes care of the heavy lifting. We start by looping through every single row and column of the level grid. This nested loop is the engine behind the board update. It ensures every tile is individually checked and refreshed. For each specific tile, we call the update tile method. Now, remember, the update tile method is where all the magic happens. It decides what each tile looks like based on its current state in the grid. Whether it's a wall, a dot, Pacman, or a ghost, update tile ensures the visuals stay accurate and up to date. So essentially, the redraw game board method is like hitting the refresh button for the entire game map. It's efficient, simple, and makes sure that the player sees the most accurate version of the game at all times. And there it is, your very own Pacman game. We have a level system that you can expand quickly and easily using a text file. You can control Pacman and he always looks in the direction he is going. The ghosts move independently and can hit Pacman. Pacman has a points and life system with visual display. As an add-on, Pacman has his power pill, which makes him a superhero, and he can replenish his lives with fruits. Not bad at all, or what do you think? Let's quickly add two little things. First, we change the appearance of the ghosts with a small update and we add a quick and easy sound for Pacman. This should always be heard when he eats a dot. So only add these lines to the ghost image creation and you see direct acknowledge in the game. This makes it more fun, or? Feel free to try different lines or values or use your own images here. The play.sound method adds that satisfying audio feedback when Pacman munches on a dot. Here's how it works. We need to add a WAV file to our project resources that we can use for this. After that, we create a sound player object. Think of it like a virtual DJ, ready to spin a specific track. The sound file it plays is stored in the game's resources, under the name dot. That's the chomping sound effect we hear every time Pacman eats a dot on the board. This line tells the sound player to fire off the sound. No delays, no loading screens, it just goes. We call this method each time Pacman gets score for the dots in the move Pacman method. Let's check if it's working. And there you have it, folks. We've built our very own Pacman game from scratch, adding every feature, every sound, and every thrilling detail step by step. From munching dots to dodging ghosts, and even activating power-ups, this game is ready to challenge anyone who dares to take it on. Take a moment to sit back and admire what we've just accomplished. You've transformed lines of code into a fully playable game, a true classic brought back to life. Now, remember, coding isn't just about writing lines of text, it's about creating worlds, experiences, and, most importantly, fun. Whether you're here to learn, improve your skills, or just love Pacman, you've made something incredible today. So what's next? Customize your game. Add new levels, throw in some crazy power-ups, or even design your own ghost AI. The possibilities are endless, and the best part? You're the game designer now. I prepared also some other maps using a text file for you. What do you think about that? Cool or? And really easy to create. So feel free to create your own level for Pacman. Thank you so much for coding along with me. If you enjoyed this tutorial, don't forget to leave a like, share your thoughts in the comments, and subscribe for more awesome projects like this one. And if you've made your own version of the game, I'd love to hear about it. Let me know how it turned out. Until next time, happy coding, and may your creativity run wild. See you in the next video.